Okay, it's starting. So good. And we are almost, I think we're live, I think. Okay. So hi everyone, thank you for joining. And this is YouTube, very unusual episode of not YouTube, Postgres episode, which is usually in Russian. But today we're going to do it in English, in experimental way because of our special guest. And I'm Nick, and my co-host is Ilya. Hi, Ilya.
Hi, everyone.
Yes, and our special guest is Álvaro from Spain. Ilya is from Germany, I'm from the US, and Álvaro is from Spain. And we're all locked in at home, right?
Yeah, of course, not completely locked, but well, recommended to avoid social contacts. Yeah, I think we should actually say a couple of words how this entire thing works. So basically, for those people who just joined and never seen this before, because usually we do that in Russian, it's like a Zoom meeting. So you can either ask questions in YouTube translation and chat, or you can use this chat in Zoom to ask questions, or if you have something to add, you can just raise your hand and interrupt us and say what you think.
Yeah, just
Basically, there are
jump
several
into
options to do this.
anytime. Feel free to jump and into our chat and ask any questions. Álvaro, thank you for joining.
Yeah, thank you so much for inviting me. And because I wasn't able to follow up with the meetup today in Russian, at least I wanted to contribute a little bit in Russian. So I got this hat.
Hat is very like it's cool. Okay, I it's very unexpected. Okay, good. Let's start. So I have some questions, and I will try to avoid touching topic of current situation in details. But let's start from very. I think we all of us are doing Postgres professionally every day. So this thing unites us a lot. And the first question is, why did you choose Postgres and like why did you choose to focus on Postgres?
You know, in my case, it was definitely by chance. I remember I was at the university, and I was working with a web app, PHP language, whatever that was, and I needed to store some data. I was clueless at the time, so I asked my colleagues and said, you know, hey, I need to store some data. I heard something like I need kind of a database. I don't even know what is this, but what do you tell me to use? And someone said, use Postgres. I said, okay, I don't know what is that, but I'll research a bit. And so I got to use Postgres, and it worked for me. And never looked back. Never needed anything outside Postgres. And Postgres has been my database from that day. That's more than 20 years ago. And has the ability, or has had the ability, to never not satisfy my requirements. So I would have looked elsewhere if I would have had some needs that were unfulfilled by Postgres, but Postgres was able to fulfill all my needs and support all my requirements. So I'm very happy, and I started this by pure chance in this case.
Sounds like you were lucky, because for me it was like number 4 database system after Oracle, SQL Server, and MySQL. Okay, but why did you choose it why did you choose to focus your professional efforts and everyday work just to devote it to Postgres purely? Like, what about this?
That's a deeper question. But basically, it started. I followed the process, moving more from the front end side of things. Like, you know, it's an easy place for us to start with working professionally. And at the time, I started to realize, first of all, that I was more interested in backend technologies, and more on this, you know, what is backend technologies and database and all data related things first place. But then specifically about Postgres. So once I realized that I wanted to work on backend technologies, once that I realized that I wanted to work on databases, because that's what I like, that was what my passion is, data in general, databases in particular. Then I said, okay, where's an opportunity? And I believe that opportunity is in Postgres. Why is that an opportunity? First of all, because it's a very, very complete database. It is very powerful, has a lot of features, We all know what Postgres can do. And there's a huge demand for Postgres. Actually, a lot of people, most of the people I've talked with, agree that Postgres is a fantastic database. Some other people will say, well, I prefer X or Y, but few people will say Postgres is a bad thing, or you shouldn't be using Postgres at all. So it has an extremely good reputation. But at the same time, Postgres has several areas where it needs some extra improvement. It needs some extra tooling. It needs some guidance. Postgres leverages on the ecosystem. The ecosystem is all these tools, right, that we have around Postgres that we actually need them to run a production workload. So typically, you just don't apt-get install Postgres and go live, right? You probably want to add a connection pooler. You probably want to add high availability. You probably want to add monitoring. You probably want to add backups. And for this, you all need tools. And these tools are coming from the ecosystem. The ecosystem is full of options. You need to be able to choose. You need to be able to understand. So there's a huge opportunity there, in my opinion, because A, there's opportunity to build these tools or to improve these tools or to build new ones that do the things that some of these tools are doing better. Second, to guide customers in which of these tools are good, how to configure them, how to integrate them, and in general, to encompass this exponential growth that Postgres has with professional services offer, where the supply of these service offerings is low, which creates, by market definitions, an opportunity by itself.
How do you measure this growth? Because I observe that, for example, in terms of I monitor job postings on Hacker News, and Postgres reached very high level. It's number one database system, mentioned in like almost 15% of all job postings, including non-technical ones like managers and so on. So it's very, very high level, but it doesn't grow anymore, like already almost a year. How like you said it's growing? Why do you say it?
Well, first of all, I rely, like many other people, on DB Engine's ranking. There you can see that it's growing steadily on a logarithmic axis, which means it's growing exponentially, right? So linear growth on logarithmic axis. But that's its popularity. But in general, first-hand experience, I see more and more companies jumping into Postgres, more and more people using Postgres, more and more tools being used to address Postgres. So other than the data that comes from places like DB Engines, which is like more objective data, from a subjective perspective, I see these. What I see is that there is a latent demand in Postgres. I see a lot of people who are jumping Postgres, but a lot of people, a lot of companies that they're not demanding yet professional services. A, because there's always this, this thought that because it's free, we don't need anything else. We'll figure out ourselves. But once things start to get a bit tougher, your workloads increases, then you really need professional help. So there's a lot of this latent demand there waiting to explode. But
because they are startups, actually. Startups do things themselves.
Startups, mid-sized companies, all of them, once they reach some certain level, they may start needing this kind of professional help and stop thinking like, we'll do it ourselves just because it's free. We're not going to pay for anything else.
Yeah, well, I may suggest in this case that actually it's sort of a catch-22. If you're trying to measure technology popularity by the job postings, it's usually like then the technology becomes very popular. It grows very fast because everyone needs those people. But now it's actually some sort of evidence of a mature technology because there are several people on the market who can do those things, and now the company is starting to adopt the thing that Álvaro is talking about. So basically, the market of the DBAs developers who can Postgres actually grown up, and now the company is starting to adopt this because people are available for that. So I do not see any disagreement between you two.
Yeah, and this is actually what I wanted to add. So I believe it's growing well enough, but we can do more, and we should do more. This latent demand that I mentioned is also because there is also lack of Postgres professionals in many areas and Postgres experts. I've talked with customers that says, we chose that all the database technology just because we couldn't find enough Postgres professionals. So that means that we really also need to push the boundaries into how to educate people into Postgres, how to get more Postgres experts out there, And this, as you said, is kind of this catch-22 that will also help again get into the next cycle of growth or hyper growth that I would love to see. So it's not enough where we are. We cannot sit down and say, Postgres is growing and that's all. We need to actually really push for this.
How?
Makes sense, man. How? With conferences, you both are like, this is where I wanted to, like, first of all, I wanted to say, I really enjoyed both of conferences you are guys organizing. Like one is pgday.ru in St. Petersburg. And actually I met Álvaro 5 years ago, I think, at that conference. And next, of course, Postgres Ibiza, right? Ibiza, pgibz.io.
Correct.
Right. And I wish you to make it happen this year, because it will be maybe difficult.
Yeah.
But like conferences is one way, right? It's a good way to organize more people meet and share knowledge. But what else? One of our to-do items to discuss actually is Crunchy. Crunchy data company. They have new section which is quite small right now, education section, and they used this tool, Katacoda tool,
Yep.
which you have like small actually Docker, I think, and inside it you can follow some exercises, and you have playground, and you can do not linearly anything you want, and try various things in Postgres. And they started to create these exercises, and I do like this idea. This is also like it looks good. Have you tried it?
Yeah, I tried it.
But this is going in this direction. I think it's a good move, and that's the key. So so what is actually blocking more exponential growth in Postgres community and Postgres users? Part of it is the lack of Postgres experts and the shortage of Postgres professional services companies, right? So how do we increase this? By more people knowing more about Postgres. How do we increase that? By education. You already mentioned this. This effort is going in the right direction, but it's tiny. And when I'm thinking of this, I always look at what other competing technologies or possibly competing technologies are doing, and look at MongoDB. MongoDB has a kind of a university online for learning MongoDB, and there's tons of material around it. We should get to a level similar to this in order to spread more the knowledge. A lot of people are now incumbents into MongoDB because they are learning from this. They have the 100 days of advent of code with MongoDB. They have exercises, they have courses, full courses online to learn about MongoDB, and they have certifications. And I know there's a lot of efforts in the community.
Yeah, and Oracle also has a lot of stuff, and so it's very powerful. And they both are multi-billion companies,
yep.
Right? Public companies, and they have energy to do this, and like they can focus on this to have whole department working on this.
Oh,
and I know
even more.
Say it again.
Energy we have even more.
Right, maybe. Right, but we are very distributed and sometimes look into different directions, right? That's why single department is with single focus. This quarter, this focus, next quarter, that focus. And I know that in Russia things improved due to Oleg Bartonov and Postgres Pro activities. But at the same time, when I see, like, it's a very slow process also.
Yeah, true.
So
yeah, that's a very huge question, actually. Postgres community always try to be as independent as could be. So basically, that's why no use of things like GitHub and things like this and that. So it's constant, constant try to be as independent as possible, as self-hosted as possible. And I think it's one of the reasons, so for communities, the only way to make the certification, which is in proper community way, so based on like open source tools, really independent from one or another company, and it's really, really hard to deliver. So basically, I'm not personally thinking that it's like near future to have some sort of certification, some sort of community certification. So it's like a much more complicated problem as it looks like from outside.
It is not easy. That's absolutely true. But on the other side, I also think that we need to really pick more carefully because of how limited we are in terms of resources, in terms of bandwidth. What we really need to aim for truly independent services or processes or community, because sometimes that's also lagging progress. With a good goal, but we cannot aim for the ideal always. So sometimes I would relax those conditions. Let's take an example. There was a couple of years, maybe even more, I don't remember correctly, that when the Linux kernel, which is also a project similar in that regards to Postgres, which is truly independent, not guided by any single company, and truly distributed, was storing source code in a proprietary repository. Definitely, that didn't work totally well, right? But still, one example that sometimes we may relax just a little bit this requirements that we self-impose to us in order to foster the bandwidth and resource that we have to make progress faster. I don't know which one of these examples is the best one to choose from, but I would like to keep this in mind in order not to look for always the ideal and also make progress faster.
Yeah, that's a good point. That's a good point actually, because we all know that there are lots of things in Postgres about which people constantly keep saying we cannot do this and that because it's impossible, it's too hard, and then someone tried and now it is here. So basically, I think from backup to replication, it's like
Replication is a very good example.
yeah,
Right.
replication is a very good example. Yeah.
Right. Let's switch to more technical maybe topics. Like I wanted a lot to talk about Postgres and containers because it's still very raises a lot of discussions in various places like forums, chats, and so on. So what do you think about Postgres and containers in general, and kinds of it, like when you have just one container on machine or using multiple containers in Kubernetes and so on? What do you think like of this idea to run Postgres in containers in production and non-production environments, like in general?
Well, I'm totally in for that. I believe it's a great fit.
No doubts.
No doubts, no doubts. I hear a lot of concerns, so let me try to address those beforehand, right? So there's two main concerns that I've heard about Postgres on containers, and if there's anyone else, please raise them on the chat. But the two main ones that I have heard is the fragile nature of containers, that they may die at any time, or they're ephemeral. And second one is about the storage, persisting data by itself. So let me address both quickly.
First is like if we run it in container, we depend on some additional code like Docker, and we don't know if we can trust it as much as we trust to Postgres code, right?
Even more than that. So some people say, no, containers are ephemeral. Containers can be killed anytime. They disappear magically sometimes, and so your database may also be gone at some point, right?
It sounds more like for cloud environment, maybe, like when whole machine can disappear.
Yeah, it's kind of related to that. So, but basically the problem is that there's a lot of misconceptions about containers. We tend to think, because it's just easy, that container is like a VM. It's like a tiny VM, right? And it's scheduled to run on some kind of magic virtualization. But that's far from the case. A container is just a light, very light wrap around a process or a process hierarchy. And it lasts as long as the process or process hierarchy lives. So if your process dies, the container dies. But if your process don't die, the container don't die either. And so that's key. Containers do not magically disappear. They live as long as your process lives. So again, if your process is not crashing, Postgres is not crashing typically, then your container will be there. And we have customers who've been running for ages on containers, no problem at all. And
what kind of ages?
Years. I mean,
years.
In container times, this is ages, right? And
it's like uptime. You mean uptime is like
uptimes of years on containers without a hiccup, right?
Mm-hmm.
So there's
in production under load.
Yeah, in production under load, with terabytes of data.
Docker
in this case.
Okay.
So there's a caveat, which is if you're running under an orchestration layer, this orchestration layer may actually at some point decide to kill a container to reschedule it somewhere else. Like Kubernetes is prone to do this. But this is something you can also prevent. There's metadata to prevent this from happening. So as long as you take these precautions, then you're good to go. The second one is about storage. Containers are not designed for stateful workloads, right? And Kubernetes is not designed for stateful workloads. Well, actually it is. First version, it was not. And the first implementation of stateful workloads on Kubernetes, like Pet sets, it was terrible. But it evolved, and now it's pretty good. I wouldn't say it's perfect, but it's good enough. It's good enough to store data and actually makes all the processes that are important for operational speaking for workloads like Postgres database. They make it very easy to run on Kubernetes, such as high availability processes that are typically complicated get simplified on this environment. The process of having a node go down and bringing back a new one, again, they're so much simpler. So actually, it could be an advantage. And in terms of performance, if there's any concern, and you actually did a lot of numbers also in these regards, overhead is minimal. There could be a little impact, but it's minimal. So
those numbers are related to Disk.io specifically, but there are concerns that, for example, we may have worse performance in terms of CPU as well. Like, and if we need to separate here different scenarios, and Kubernetes is an even more advanced topic, but also, like, as I've said, if we run just one single container on machine, or we trying to have multiple containers on machine, and Kubernetes actually is lies in this area, and then we also want to somehow limit resources, right? And using Docker capabilities, and like it may, first of all, it may not work in some cases, not work well, and second, it should add some overhead in terms of work with memory and CPU in general, not just Disk.io.
From the performance overhead part, I haven't seen anything noticeable at that point. Again,
this is interesting because, like, how can we measure it? And I remember with Ilya, we recently in offline conference, we recently talked about it. I don't remember details. It's really not easy to measure and compare the overhead. Which,
well, to start with, it's really not easy to measure that, because basically you need to have a bare metal installation and run, I don't know, perf top or something like this, and compare that to Docker, and would not work
with same
quite
hardware.
well actually. Yeah, so it's really difficult to measure this overhead. Another good question is actually Docker over the years it evolved quite impressively. So basically, like IO architecture by Docker is not just something very stable over years. So basically, I don't know exactly on what sort of IO in Docker you are talking about. So basically, which way of handling disks in Docker you're speaking in terms of there is no performance overhead?
We considered PG data mapped with -v and just running it without Postgres, and the overhead was a couple of percent. We used a lot of PG benchmarks and like TPS oriented, latency oriented. It's public. I will share links. It was long ago, actually, like more than 1 year ago. And actually, interesting. First, we observed 7, 8, or up to 10%, but it turned out that we compared different bundles actually, and we compared, first of all, Ubuntu 18.04 versus 16.04, and Docker was created on one Ubuntu, was running on different Ubuntu. So it looked like we first compared not over we were measuring not Docker overhead, Docker IO, Disk.io overhead, but measuring different versions of operational system, libc, and Postgres. I think Postgres was the same, so like the same minor versions. And it's very like if you created image on one Ubuntu, but running on different Ubuntu, it might performance may be slightly different than expected, right? Because it's
That's
just libraries are different and
because you
kernel.
know Docker is very convenient thing. It's like it reminds me typical dialogues between Java fans and haters back in times, and people used to tell that bytecode is very universal, and yeah, and immediately people start to discuss that if this compiled on Sun or this is on Linux, yeah, we have some
Right. So you
problems.
bring in different libraries to different kernel version, and you should be careful with it, right? It's better to maybe it's better to always create your own images and run own like containers which you trust fully. Maybe I don't know.
You know, I think we should also give a little bit of a background on what exactly a container is, because again, I'm trying to convey the message that is not really like a light VM. And because if you think in terms of a VM, you might get to think, oh, there's some virtualization overhead, and then we need to measure it. There's no there's no virtualization like of CPU or OS or system calls or anything like that. So what is really a container? So in a very simplified and layman's way, a container is a wrapper around the process. And this wrapper may or may not actually abstract you only of three things. One is the IP/port address space, the TCP IP address space. Second one is the process space, and the third one is the file system space. And actually, you can pick the ones that you want. All these are provided by the Linux kernel, and they're very efficient. They're very efficient. And file system space, if you're using external storage, which is obviously the only thing that we're talking about here, because if you're using container local storage, which is definitely ephemeral and performance is very bad because it's typically layered on top of an overlay file system or equivalent, that is generally not.
And all changes will be lost if it's restarted.
It's ephemeral. So we're not talking about that anyway, right? So we're talking about external storage, and it's just mapped into the process space, very simple, very direct manner. That's why it has almost no overhead. In terms of file system, so it's there's no overhead from that regards. Processes, you don't really care. You see only your own processes, and that's pretty much it. And the other one is IP port space, and it has been virtualized on Linux for ages, this kind of decades, right? So it's not an issue. It's not an issue from this perspective. That's why there's typically low overhead. Even if you would find, okay, let's say you find a 3% overhead, even a 5% overhead. Well, when you virtualize, you also find an overhead compared to bare metal. And the discussion here is, even assuming there would be a 2, 3, 5% overhead, which I haven't seen yet, compared to the conveniency, I'll pick conveniency. With containerized environments, you can really leverage a lot of other operations for the architecture of your environment for high availability, which saves a lot of problems, much more what could be a 2 to 5% performance degradation, which again, I still have to see.
This is very good opinion, and actually I have some like summary from that very long discussion which lasted multiple days in some Russian Docker related chat. The opinion is like there are questions like if Docker adds some layer between database system and operational system, and due to that we fear that there is some overhead, performance overhead. How can you comment this opinion, like a layer? I think you just answered, but just let's repeat this once again.
Yeah, actually, the first thing I would say is that containers are not Docker. Docker is one example of a container runtime. There's other container runtimes, and I would say that some of them are better than Docker.
Podman, right? There is alternative.
For example, on desktop, I use Podman. On servers, Containerd and like CRI are pretty good. But there's many actually out there. So the layer Docker adds typically that is criticized, and I jump into those too, is that it runs as a daemon that communicates in a client-server architecture and requires root privileges for because it's how it was designed. And this is absolutely not necessary. Again, you're a user launching a process on your own permissions. It's just you're getting some help from the kernel to virtualize your process space and your file system space and your IP address space. Other than that, it's just a process. If you run a command line program from your
communicating through Unix domain socket, so just very normal for operational system.
Yeah,
Right?
yeah.
Between processes, right? Right. So it's not a layer.
It's a thin wrapper over a process or process hierarchy, and as such, the overhead should be minimal, especially if you're using, of course, external storage.
And we have good comments from Alexander Kukushkin, who is expert actually in this area and was one of our guests in our latest episodes, but unfortunately only in Russian. So he said that there are two major issues with Kubernetes, Docker, and C groups in general: OOM, so out of memory killer, and CPU quotas. If you don't provide resources enough, it will be either killed or throttled. So there are two problems. And what do you think about these problems?
To be completely honest, it's an issue on the bare metal as well.
Yeah, actually, yes. So some people prefer to use swap, for example, and to be insured from out of memory events. Like
just by using Docker, you actually make it easy to OM killer actually to kill everything, because well, if it's Docker process, it's like a good candidate to be killed.
And as I remember, Alexander explained that there are some situations which are hard to troubleshoot, and it's different from regular OM.
There are some differences, but this also resonates with one of the comments / questions that you made some minutes ago. What is the best practices? Should I run many databases and many containers on a single host or not? I would advise to follow the same best practices. Forget about containers is just a conveniency for deploying and operations. But again, if we stop seeing containers like VMs and we see containers as just the processes that we are, is it a best practice to run on production workloads several Postgres clusters within the same bare metal system or VM for that matter? Typically, the answer is no, unless you're really going really big iron and on purpose multi-tenancy of several Postgres clusters. You typically have a single Postgres cluster per VM or physical host. So the same would apply here. Just run a container. Now, the containers make your deployment and operations simpler, but you don't need to now cram a lot of them into the same host, because you're not doing this in non-container.
In this case, we don't care about quotas, right? Like if we run.
No? I had that nice slide in my worst practices talk for Postgres. Like people do put their primary in one container and hot standby in another one and put them to the same machine. That's like no way you do that correctly.
Correct. Yeah.
It's a good thing for test purposes, but well, of course, it's a bad idea.
So for production, advice is to run only one container on one virtual machine for Postgres, or
yeah,
what?
I mean, different stories. If we go deeper, I would like to say that I love the Sidecar pattern, and this is a pattern where you split a given workload, let's call it that way, into several different aspects, and each of these aspects may be a single container which they work together. So if we focus on Kubernetes more specifically, because it has wording specifically for this, the unit of workload is a pod, and a pod can contain one or more containers. And those containers that execute within the same pod, you can have them share part of these namespace abstractions that I was referring to before. So for example, these containers may share the file system. They definitely share the IP address space, and they may also share optionally the process space, which means that, for example, when you take Postgres, you typically don't run Postgres by itself. You typically run Postgres, and you also run a connection pooler next to it, typically. Or Patroni for high availability, or Postgres exporter for exporting metrics to Prometheus. All these containers are, all these services adjacent to Postgres, they are, from an aspect-oriented perspective, they're separate. Why not build separate containers very specifically. So you'll build an excellent container for the Postgres exporter. You'll build an excellent container for Postgres connection pooling. You'll build an excellent container with probably Postgres and Patroni. This case is slightly different. Maybe you also want some kind of network proxy like Envoy. Then you'll build another container for Envoy. Now you put them all together. And this is, separation of concerns, divide and conquer, call it whatever you want, useful principles in software science. And then you make them work together. And this is very simple, again, Kubernetes style way of thinking, and you may leverage this. So the answer is maybe yes, run the equivalent of one pod per VM or physical host for your Postgres workload, but maybe your Postgres workload is itself composed of several smaller containers which contain the different elements. Just for clarification, what I wanted to say about Patroni and Postgres is that Patroni, it's not an agent next to Postgres, but as you know very well, it's rather a parent process to Postgres. So Patroni starts and stops Postgres. And from that perspective, Patroni and Postgres are part of the very same Postgres process, hierarchy. So they are actually the same container, but the rest of them should be separated.
Mm-hmm. Oh, mm-hmm. By the way, talking about the convenience, actually, as far as I understand, many DBAs actually quite enjoy the idea that on bare metal they can go inside like operating system and figure out what is going on. As far as I understand, hence it is a quite possible way to scrutinize Docker as well, but it's not the popular way to go inside the container and figure out what is going on, etc. So it's probably for many people, it actually is some sort of a downside in terms of usability. Only for those who actually orchestrate different clusters, lots of configurations, maintain lots of configurations, the idea putting Postgres in Docker brings a lot of convenience. What do you think about this?
Well, I think that, of course, there's no free lunch, right, anywhere. So you need to also have some disadvantages or some new things to learn or some different approaches to some processes. But in general, I would say you can still approach from a DBA perspective, and I'm speaking as a DBA myself, the same way of managing a Postgres cluster running on Docker, for that matter, than you would do that on bare metal. Yes, there would be at some point some limitations. For example, because you're running a container, and container is a process, not a VM. You're running a different kernel. So you're depending on the host. And if you cannot have access to this host, like what happens if you're running, for example, on a managed container service on a cloud vendor, then you don't have access to the kernel. And if you want to load a module onto this kernel, you may not be able to do that. Sometimes you can do that too, but in general, you may not be able to do that. Is this a limitation in practical terms? I mean, yes, there are some certain things you may not be able to do, but typically there are not that many limitations. And actually it's just an exercise of developing slightly different practices. Let me give you an example. I was talking about these sidecars, these containers that are next to the main Postgres and Patroni container, like connection pooling, monitoring, whatever. I typically also add yet another container, which is, I typically like to call it Postgres util, which contains tools like pSQL. Why this is not in the main container? Because the main container, a container again, is a process, is a running process. What do I need on this container? Only the binaries and supporting libraries and maybe config files. I need to run this process. Postgres process is called Postgres and doesn't need anything else. I mean, shared libraries, but doesn't need pSQL. So if you want pSQL, you can put it on a separate container. And this container,
I want a lot. I want IOStat, IOTop, and so on, like dstat, htop.
All these tools you can
not everything will work inside container.
Most
not
will.
Everything.
Yeah,
yes, most of them, but either IOStat or IOTop will not work, as far as I remember, due to some, maybe IOTop, I think.
I think as long as you have access to /proc, which you have access from the containers, yes, the process is virtualized. So you don't see the whole stuff.
Right,
actually,
right, but some
explicitly mount those inside of the container from the outside if you need that. So I mean,
well, to be completely honest, if we follow the ideas Álvaro explaining us, that we run one database on bare metal, but actually inside the container,
and inside virtual machine usually, actually, also.
Oh wow, okay.
One virtual machine with one container. That's it.
Yeah, you you know that old joke Magnus explained us about how to achieve the serverless architecture. You put on server virtual machine. In this virtual machine, you run another virtual machine to run Postgres, and then you actually put the server from that first virtual machine, and your architecture is serverless.
Right. Remove the physical server.
Yeah,
Right.
carefully remove physical server.
Right.
Now, what I would like to say is, okay, there are some things that might change, and actually there's a few other areas where you need to take care with containers. Shared process, shared memory area by default are smaller than you may need. So there's some tuning that you might need to do, like like in any new environment. There's actually nothing out of the ordinary. Now, what I would say is, what is the conveniency of those of this approach? Yes, to be clear, 1 year ago, I started a project on my company to develop an open source software to be able to run Postgres on Kubernetes. And the main reason I started this project is because I realized I was doing the same job all over again for most of our customers. And this was a complicated job, and it was hard to automate. And we're a company, we love automation. We do all that we can as infrastructure as code. And we were not able to do this because all environments were different. So the problem we were trying to solve, that we realized, is that whenever you want to deploy a Postgres in production for a serious enterprise environment, you need a lot of tools around. I already mentioned examples. You need Postgres itself, high availability, you need backups, you need monitoring, you need configuration tuning, connection pooling, and many other tools around. If you try to pull all this together, identify from the Postgres ecosystem what are the best tools, and configure them all to work together, and then optimize this for the given environment, and then set up the entry point and do a DNS or a high availability proxy or HA proxy or whatever to set up the entry point in case of a failover, and then you deal with the storage, and then you deal how to create a new server from scratch with one dice and reconnect to the cluster automatically, and then you want all this to be IAC, infrastructure as code. This is a work of weeks for an expert. And then because environment changes, you go to the next customer, yet another weeks, typically actually months in reality to do this in the next environment for the next customer. And this is a waste of effort, and this prevents the barrier we were talking about at the beginning. How do we make this easy for people to get into Postgres? This is actually really complicated. To deploy a Postgres in production with all these tools around, I would say is extremely complicated task. So the software that we have developed, you can deploy a Postgres cluster with all these elements, with connection pooling, with high availability, with automatically node recovery, with monitoring, with centralized logging, and many other characteristics in literally a few minutes. And typically you can do this under 1 minute and with a small YAML file. And this is unprecedented, I would say. This is something that should Postgres usage a lot, and then reduce this effort from weeks or even a couple of months down to minutes. And this conveniency, if I need to, I'll lose a couple of abilities to introspect workloads, might be justified for many.
It's very typical approach for developers, as far as I remember. Actually, to write the script which governs it all for a couple of months, and then just run the script to make it do all the job for a couple of minutes. So basically, you configure your Docker deployment for like many years, and then you can deploy that in minutes. Yeah, but well, it's a good approach. So basically, it returns us to the point, and we actually understand that bare metal installations work well, but then actually amount of different configurations you need to maintain, like PG balancer, all this environment around Postgres, and it started to be complicated. Actually, using containers with Kubernetes actually saves time.
Mm-hmm. I would like to connect dots here. Actually, we discussed education, and I wanted to say, but like postpone it, because the fact that cloud providers simplified like barrier of entry to Postgres. You can start Postgres very quickly and start using it, right? And before you needed to to install it and then deal with PGHBA configuration and cannot access, cannot connect due to some reason, and switch to MySQL, right? Sometimes I observed such very sad situations. So they did it, but they are very like not open source friendly, actually, right? We know all this. Many cloud providers are not open source friendly, so you cannot, for example, migrate simply say from RDS to EC2. You need to deal with logical replication. Unfortunately, we don't have time to discuss it. I wanted to discuss logical decoding and replication in Postgres, not today. So, and what I try, like you're discussing your product Postgres, right? And I will put a link to Hilot talk you did. We have YouTube video, and everyone can watch it, and it was good in Moscow, actually, in English also, which is good. So and you're actually trying to fill the area when we want the same benefits, but not being locked to some cloud provider, right?
Correct.
So it's not only about technical administration issues, it's also about entry, like how to start using Postgres quicker.
Yeah. So yes, this software I'm referring to is called Postgres, and this is open source software. It has two main goals. You spotted it very correctly. One of them is to lower the user entry barrier. As I mentioned before, building all this stack of components around Postgres that you need for like an enterprise experience, it's very complicated. It takes a lot of effort, even for Postgres experts. If we could automate this, as Ilya was saying, and take all this script, actually the script is of today is like kind of 50K lines of code, so it's not trivial. But anyway, if you could take all these and bundle into a package that will say, hey, install this and I have a Postgres cluster with connection pooling, with high availability, with monitoring, with all that in place, that would be amazing for users, because they now longer, they don't need to be experts. And actually the way you interact with Postgres is via YAML files that expose primitives of a very high level. So you don't need to talk about Patroni or replication or pghva.conf or anything like that. You just talk about clusters, number of instances, what profile do I have for the instance, which is the CPU and RAM, and so forth. The other issue is what you're referring to as cloud independence or environment independence. So how we were able to pack all these components into a single deployable distributable unit. And the fact is that every environment is so different from each other that it would have been impossible without creating a specific version for almost every environment. This is impossible in practical terms, right? So we looked into a way of how we can abstract away the infrastructure on which this system, this distributed system, is going to run. And Kubernetes was the answer, because Kubernetes is an API that abstracts you away from the infrastructure. So it doesn't matter whether you're running on Amazon Cloud or Google Cloud or Azure Cloud or whatever cloud, or on-prem or on your own laptop. It doesn't matter. As long as you fulfill your calls against this API, you'll be good to go.
Does it work in Minikube?
Minikube, absolutely. Minikube, ADS, whatever. And so deploying against this API, you can deploy the same thing. So it works anywhere. And yes, it would help you definitely to move you across clouds or on-prem environments with almost full transparency.
At this point, I should pretend to be like a typical old school grumpy DBA who is hated by all the developers and DevOps, and ask some question like, okay, we deployed using this tool our Postgres co-installation with all PG bouncer, with I don't know, PG backrest, things we want to use in from our Postgres co for example, we have a particular task which quite common once a year or something like this. We need to upgrade something. So how it works actually in this regard? Because if I'm old grumpy DBA and I get the message that I need to upgrade all the things as a package, I would have a heart attack and my cluster will go down because of that, I think. So how is all this problem actually?
It's actually a very interesting question. So there's two answers to this. The first one is that you can still solve it the old school way too. I mean, let's be honest. Doing this old school way of on a non-containerized environment is going to be a pain also.
Yeah, for sure.
Now, actually with containers, it gets simplified because let's say you want to do a minor version upgrade. Let's start with the easy case first, right? A minor version upgrade just need to prepare the new binaries. In the case of containers, you'll need to prepare the new images. So restarting a container is as simple as swapping it out. It means stopping the process. Once you stop if you kill Postgres, container will die because again, the container is a wrapper around the process. So the process dies, container dies. You restart it again, or actually if you're in Kubernetes, it will start up again automatically and it will come with the new version already because you already prepared it and you're done. So yes.
And let's hope that Patroni will not perform failover at this
okay,
moment.
Patroni is going to be a different story, right? But basically, the basic concept is that you'll prepare the new image, you'll train your new laptop, and you don't need actually to install both versions of the Postgres binary on the same place and then swap versions and restart different processes and deal with init or whatever. It's actually much simpler in this regards. Now, the cool thing about environments like Kubernetes is that they also, because of this API, leverage you to do more advanced things. They're not obvious, but you can do them. For example, on Kubernetes, you have these elements called controllers that form part of operators. And a controller can take controlled actions, programmatic actions against the API. So one thing you can do, and for example, this is coming on Postgres in the next version, is the way to do automatic minor version upgrades. How does it work? It's actually quite evolved and quite advanced. But basically what you do is that the controller knows exactly in which order the containers need to be restarted, how Patroni needs to be notified about this, and that it also knows that you need, for example, to drain the traffic first. And the algorithm is pretty straightforward. You first create a new node, you add this node and start replicating from the cluster, and as another secondary already running with the new minor version. Once this is fully replicated and all caught up with the replication, you select one node to kill, still secondaries. You first drain the traffic, which means call the proxy layer in front of it and wait until all connections are left and the cluster has no connections so as not to kill anyone, and then you kill the node. Then you repeat this process with all the secondaries, and once you're done with the secondaries, you perform a control failover, draining the traffic beforehand, and so forth. This is pretty straightforward, and when you do it on a physical or virtual or non-containerized environment, you need to do all this by hand. However, even though it's complicated, you can automate this with an operator inside an environment like Kubernetes. And then the end experience that we actually are aiming to have for users is to just watch a screen with nodes appearing and crossed out, appearing with the new version. So it's fully automated, basically.
You're performing like it's called rolling upgrade, right? So you're doing why not just restart and that's it?
It depends on the user. Some users may tolerate the downtime of doing it all at once. Some users may not.
Do you do manual additional checkpoint before regular shutdown checkpoint happen when you shut down the container, or just to speed things up?
This is all programmable, and actually, so this is not developed yet in our case.
Okay.
But it will
it's interesting because it can be fine-tuned for large for databases under heavy traffic.
Yeah, because those upgrades have lots of nuances actually, and
yeah, let's start from small topic, minor upgrades.
Yeah. So basically, it's like lots of things to do. But actually, another good question is if you only need partially upgrade things. So basically, you do not for example, okay, you need to only upgrade Postgres and do not touch PG Bouncer and do not touch something else. So the complexity of programming such upgrades is actually pretty impressive in this regard.
Well, actually, because if you remember before, I mentioned that in our case, I mean, others may not be doing this, but in our case, we're separating functionality. So Postgres is one container, PG Bouncer is a totally different container. They just share the process namespace and the file system namespace. So actually they can connect through Unix domain sockets and they see each other processes, but they're separate containers. So upgrading one is
different process of upgrading, right? So you can command to upgrade PG Bouncer
and for sure you have some mechanism of keeping an eye on dependencies, because then you have 10 containers with different Postgres things, and then you realize that this version and this version isn't compatible. How you manage this? Because it's actually it's not an easy thing.
I can, like, philosophical answer is this is what Postgres is for. right? Because to test thoroughly and deliver well-tested combinations of software pieces, I think, right?
Yes, absolutely, absolutely. I don't want to focus this on the software we're developing, but we call this a Postgres distribution. So what is a distribution? A packaging of components that the publisher makes sure that they work well together. So pretty same story. We package them and we make sure that they work well together. There's not so many incompatibilities when, for example, you're connecting over the Postgres protocol, which has been stable for so many years. But from versions to versions of some old components, yes, there are. But anyway, yeah, Nikolai, you're right. It's all about testing at the end of the day and actually understanding how the world works. Fortunately, what we're trying also to do here is to package all of our best practices and the experience that we have so that others do not need to know also all these concepts and they can just leverage them.
And actually, we're almost out of time. And I have one question, and also audience have a couple of questions. First is, at what stage Postgres right now is 0.8, like
Yeah.
almost soon will
So
be ready
it's
for
in
production?
development stage right now. All development that we're doing is open. All source code is open. All issues are on GitLab. You feel free to go there and comment anything. Roadmap is also public. So we're working against version 0.9, which is going to be due in some weeks, probably in April. And after this, there will be a long stabilization period to reach to 1.0. But probably will not be very long anyway. So just a few months. So I mean,
you can have 0.10, 0.11 as well. Just to know.
Yes, I know. But no, we're going to 1.0 directly. So after shortly after 0.9, which will be probably April, we'll call it 1.0 beta. And after that, the issues will let us know when we're ready. But we're aiming for summer release. And anyway, there's already teams using it in production. We ourselves are using it in production. And some big companies are already using it, preparing to use it in production. It's very stable because it's just Postgres. At the end of the day, what we're doing is orchestration, is programming around it, but at the core is just Postgres, and Postgres just works.
There is a question related in chat related to Postgres in Kubernetes. How exactly to persist data in Postgres Kubernetes deployment?
Okay, so shortly speaking, there's Kubernetes provides a lot of storage options. The native storage that Kubernetes supports, which in turn has a lot of different options, and even you have plugins for a lot of different options. We're targeting standard Kubernetes because we're not targeting any particular environment, and the main technique is called persistent volumes, or PVs, which is a way of connecting to external storage. In the case of a cloud, they will typically rely on network disks on the cloud, like EBS on Amazon, for example, or PDs on Google, and also can work on local storage or distributed storage when you're on-prem. There's many options, and it's all relying on proven external storage.
Mm-hmm. And also a question not related to containers Kubernetes. What if we disable swap? Like, is it a good idea or no? Like, I recently saw. We also I can put it to our notes. Bruce Momjan was in Russia again, and he had good training, new version of his training, how to tune Postgres hardware and so on. And he suggests to have some small amount of swap just for safety. But it's also like in Linux, swap is working that way that we may not be like, we may want to keep it, at least some amount of it, right? But some people I see disable it. What do you think? Like what both of you think, because it's like very interesting and discussable topic.
My short answer is keep a bit of swap. My experience tells me that Linux kernel works sometimes in a bit strange ways when there's no swap at all, and a bit of swap helps. And the algorithms for the BFS are pretty good, and in general, I would say so.
Like some gigabytes, right? Or
yeah.
What is your advice or approach to tune?
Yeah, well, it's actually a very arguable question, most likely because most people quite good understand how overcommit of memory works. So basically, you said not overcommit a swap, and then your virtual memory is just your physical memory on your server, not physical memory plus swap. That's a transparent thing. But actually, how swappiness, VM swappiness parameter works. Even people who are quite experienced in hacking Linux kernel, they cannot answer that clearly how it works. So basically, from our experience, usually it's a good idea to keep it reasonably small. If you switch it completely off, like 0, most likely you will have immediately some problems with OM killer, and maybe it would be like your Postgres or something like this. If you keep it like 1, which we generally recommend, it works. It practically doesn't, your database or another software on the server practically doesn't use swap, and that's actually a result you want to get. But basically, if you set that to something in between, like 6, 10, some people advise those things, it works pretty much the same way. So basically, by default, it's too much. It's like 60. So basically, it's some sort of use swap sometime. But if you actually play with this setting between 0 and 10, it doesn't make any sense. So basically, 1 is good option to start.
Okay.
And actually, we calculate carefully how many memory you have, and just keep an eye on your work map.
Especially if you use shared buffers, 80% or something of RAM.
Yeah, well, if you're using shared buffers 80% or something, you most likely use huge pages to that. So in this case,
But
swap is not relevant to you.
It's still very not well explored area to use a very high amount of, like large amount of shared buffers for me. For benchmarking and so on, we did it a lot, but for production, still like it's better to be
It's really hard to benchmark. It's really hard to benchmark. It's like more about real time.
I know very well how hard it is.
You spend a lot of time on that.
Yeah. Okay, thank you guys. It was very interesting discussion. Unfortunately, we are out of time, and I want to say I wanted to say like subscribe to our channel, but this channel is for Russians. Like we
probably we can do more international versions.
Let's see. But definitely, please put likes there, because it will help to give more audience, to take more audience. And thank you, Álvaro. Thank you, Ilya, for this discussion. Have a good day.
Thank you. Have a good day.
Goodbye.
And stay healthy.
Yeah.
Bye-bye.
Goodbye.
Bye.